All right, number 13. We want to determine the location and value of the absolute extreme values on the given interval, if they exist. So we're given f of x, negative x squared plus 9, and we are on the interval negative 2 to positive 4, the closed interval, negative 2 to positive 4. All right, we're going to find the derivative. That's going to give me a negative 2x, so power rule, and then that'll go to 0. Derivative of a constant is 0. We're going to set this equal to 0. So negative 2x equals 0, divide by negative 2, and we get x equals 0. So x equals 0 is a critical value. From this point, we are going to plug in the endpoints and the critical value, and then we'll see which one gives us the highest and the lowest value on this closed interval. The property says if we are on a closed interval, we are guaranteed to have an absolute minimum and an absolute maximum on the closed interval. So we're going to plug in negative 2. That's going to give me a negative 2 squared plus 9. So that's going to be a positive 4. It goes back to negative 4. And that gives us a positive 5. So at negative 2, we get positive 5. We can plug in 0. That was our critical point in the middle. So we get a negative 0 squared plus 9. 0 squared is 0. Still 0. This is going to give us 9. So at x equals 0, we get a y value of 9. Now we'll plug in 4. Negative 4 squared plus 9. Okay, 4 times 4 is 16. It will become a negative 16. So we have negative 16 plus 9. And this will give us negative 7. Okay, so of these values, the endpoints and the critical value, this is the max, highest number. This is the minimum. Okay, negative 7. Minimum occurs at 4. Maximum occurs at that critical value of 0. All right, so it says what is / are the absolute maximum minimum on the interval. Select the correct choice. So the absolute maxima is 9, and it occurs at x equals 0. All right, and then the absolute minima, the smallest value on this interval, was negative 7. And it occurred at the x value of 4.